Hello and welcome everyone to the world of physics. Today we are going to start with a new chapter, that is the temperature measurement. Before understanding further for the temperature measurement, we must understand the difference between temperature and heat. And in order to understand that, we must know what is heat and what is temperature. So basically, heat is the form of energy that is transferred between a system or an object with a different temperature, that is flowing from a higher temperature system to the lower temperature system. Whereas temperature is nothing but it is the measure of warmth or the coldness of an object or a substance with reference to some standard value. We know about the standard values of the temperature, that is 0 Kelvin or 0 degrees centigrade. So that is ultimately the idea behind the heat and temperature. Heat is nothing but a form of energy and temperature is nothing but a measure of warmth or the coldness of an object, okay, with respect to some reference values. So let us talk about the difference between heat and temperature. So whenever we talk about heat, we know that heat is an energy. So heat is one form of energy. It is a thermal energy. Whereas temperature is not an energy. It is the thermal state of a physical body or a system. It is nothing but a thermal state of the system. Heat transfer is a reason behind the temperature change. Whereas temperature variation can be the result of gain or loss of heat. If we say the temperature is decreased, means the heat is lost. If we say the temperature is increased, we can say that heat is gained. Okay? So heat is exchangeable. It can flow from one body to the another body. Temperature is not exchangeable. Only heat can be exchanged. Okay? Fourth point is the total amount of heat present in a particular body cannot be measured. It can be measured only during the flow of exchange. Means whatever the heat is accumulated inside the body, the difference can be known, but total amount cannot be known. Okay? Whereas temperature of a particular body can be measured. Moreover, temperature does not flow. Next point is heat flow between the two bodies does not rely on the amount of heat present in the bodies. Whereas temperature that decides whether or not heat flow occurs between the two bodies. If the temperature difference is positive, means that let us say T1 is higher, T2 is lower, means heat will flow from higher temperature to lower temperature, that is from T1 to T2. If T2 is higher, T1 is lower, then heat will flow from higher temperature to lower temperature, that is from T2 to T1. Means depending on the value of temperature between the two bodies, the heat flow direction will be decided. Heat always flows from higher temperature to the lower temperature. Next point is heat is not a fundamental property of matter, whereas temperature is the fundamental property of matter. Further moving, heat is not a property of thermodynamic system, whereas temperature is one of the property of thermodynamic system. Mainly it is more prominent. Okay, most important property of the thermodynamic system is the temperature. Heat is a path function, whereas temperature is a point function. We know that heat flows from one body to another, means it has a particular path, higher temperature to the lower temperature. Whereas temperature, that is, it is sensed at a particular point. Okay, so that is why temperature is a point function and heat is a path function. Now next is the temperature scales. What are the various temperature scales available in the market? So we know that basically there are three temperature scales, that is Fahrenheit, Celsius and Kelvin. Now basically we all know about the temperature scales of Kelvin and Celsius, as it is widely used in SI systems, and in the gas law you might have converted the temperature in centigrades to the Kelvin, because the gas law is followed by the rule of that Kelvin scale of Kelvin only. Okay. So in that particular examples in the 11th and 12th science, you might have converted the temperature from degree centigrade to the Kelvin. So it was purely like that. 25 degree centigrade is nothing but 298 Kelvin, or else 27 degree centigrade is 300 Kelvin. So what is the rule over here? Kelvin is nothing but it is equals to 273 plus whatever the degree centigrade is there. So K is equals to 273 plus C. You can see the rule mentioned above. Now similarly for the conversion of Fahrenheit, there is a rule F is equals to 9 by 5 into C plus 32. Or else instead of 9 by 5 you can say that 1.8 into C plus 32. So if you think that at 0 degree centigrade 273 Kelvin is there. Okay, at 0 degree centigrade 32 degree Fahrenheit is there. Okay, now my question to is there any value present at which degree centigrade and Fahrenheit both are equal? If you want, you can pause the video at this moment and try to calculate it by yourself, or let me directly give the answer to you. At minus 40 degree centigrade, the Fahrenheit conversion will be equals to minus 40. If you can see, let us say F is unknown at moment and C is equals to minus 40 degree centigrade. So minus 40 into 1.8, that will result into minus 72. Minus 72 plus 32, which is equals to gives to minus 40. So minus 40 degree centigrade is equals to minus 40 degree Fahrenheit. Okay. So this is the relationship between the Fahrenheit scale and Celsius scale, Fahrenheit scale and Kelvin scale. So you must remember all the conversions. Let us say in the question it can be asked like somewhat degree centigrade is Kelvin is there. Let us talk about 200 Kelvin. So what is the Fahrenheit value of that? So first of all, convert 200 Kelvin to this degree centigrade, and then after convert degree centigrade to the Fahrenheit scale. Okay, so thus by converting in the two steps, you can convert it into Fahrenheit. Kelvin to Fahrenheit conversion can be made. Okay, so that's the overall idea. Now let us talk about the measurement of temperature by different methods, and the first and the basic one in that is the RTD. RTD stands for resistance temperature detector. Okay, so it is nothing but it uses a modified version of the Weston bridge. In that, one of the element is the resistance element, and we know that the change in resistance is occurred because of the change in temperature. Okay, and by using this rule we can calculate the temperature. So as shown in figure, you can see over here the RT is the resistance element. Over here R1, R2 and R3, and this RT consists of a Weston bridge. The output of the bridge can be sensed by this voltage at the center, and S is the power supply over here. So resistance thermometer are known as a resistance temperature detectors, RTDs. Are the sensors used to measure temperature. Many RTD elements consist of the length of the fine wire wrapped around a ceramic or a glass core, but other constructions are also used. RTD wire is a pure material, typically platinum, nickel or a copper. The material has an accurate resistance or temperature relationship between which is used to provide an indication of the temperature. Means over here in this system, temperature versus resistance is purely linear relationship is there. As RTD elements are fragile, they are often housed in protective probes. Okay, so we have discussed earlier they are kept inside a ceramic or a glass core, so they are nothing but a protective shells of that. RTDs which have higher accuracy are repeatedly and are slowly replacing thermocouples in industrial application below 600 degrees centigrade. Means RTD has a maximum temperature sensing range of 600 degrees centigrade. So this was all for today's lecture. In the next session, we will discuss about thermocouple and the remaining temperature measuring devices. That's it for today, guys. Thanks for watching.